Let's look at example 26. Prove that tangent x over 2 equals to 1 minus cos x over sin x. Okay. So before we go to the details of the proving, so these are some of the important formulas that we're going to use to answer this question. Okay. Now let's look at the right hand side of the equation. You are given 1 minus cos x over sin x. So what I'm going to do is I'm going to replace this cos x with this one. Okay, so third option for cosine identity. Okay, the reason why I choose the third one is I want to eliminate this one. Okay, so 1 minus 2 sine square a over 2 divided by, and I'm going to replace this sine x with the sine rule, which is going to be 2 sine a over 2 cos a over 2. And let's simplify this. We will get 1 minus 1 will be eliminated, and then minus and negative will become positive. So you'll get 2 sine square a over 2 over 2 sine a over 2 cos a over 2. Okay, and we can simplify this further, and what we will get here is sine a over 2 divided by cos a over 2, and sine over cos is actually equivalent to tangent, so we get tangent a over 2. Okay, so in this case the right hand side is equals to the left hand side. Okay, so it's proven. And now I'm going to teach another way of answering this question. Okay. So earlier we already learned that tangent x over 2 is actually equals to sine a over 1 plus cos a. Okay, so I'm going to multiply both numerator and denominator with the conjugate of 1 plus cos a, which is 1 minus cos a. So it's 1 minus cos a, and then when you multiply the denominators, so you'll get sine a 1 minus cos a over 1 minus cos square a, and you can substitute 1 minus cos square a with just sine square a. Okay, so at the numerator we have sine a 1 minus cos a. Okay, and when you simplify this, you'll get 1 minus cos a over sine a. Okay, so we already cancelled the sine a, because sine square a is actually sine a multiplied with sine a. So we able to eliminate the sine a at the numerator. Okay, so in this case the left hand side is now equals to the right hand side.